So I want to remind you again that all the homework reopen, and they are due April 27 next Monday, and then the final exam will be on April 28th on Tuesday. I haven't heard anything about the final exam yet, so it's gonna be online. That's all we know. Um, but I'll send you another email about the details as soon as I know about the um, final exam. Any questions? Okay. Right. So today I want to finish up section 4.5. There's just one last thing that I want to mention today. It has to do with the definite integrals. Okay. Of odd and even functions. Okay, so first of all, so what was the definition of odd functions again? So what does odd function look like? So an odd function on a graph, an odd function looks like, it looks something like this. I mean, okay, so this is one example. So the formal definition is, we say that a function is odd we say that a function is odd if when you put in negative x, you get negative f of x. So this is the definition of odd. And in this case, if I'm taking the integral from negative a to a, so let's look at this example. This is an odd function, and let's say I want to take the integral from negative a to a. So what do you think? What do you think the integral is going to be? Zero. So from the graph, you know that, oh, okay, so we know that the definite integral is the area above the graph minus area below the graph. And because the function is odd, that means the, there's an equal amount of area above x and below x. And so when you subtract them, you get zero. Does it make sense for everyone? So for odd function, if you're taking the definite integral from negative a to a, for example, from negative 5 to 5, it's always going to be zero. Questions? Okay. And for even functions, okay. Okay, so for even functions look like this. So this is one example of even function. I'm not saying that all the even functions look like this. I'm not saying that all the odd functions look like this. I'm saying that this is one example for odd function, and this is one example for even functions. And yeah, so the formal definition is we say that f of x is even if when you plug in negative x, it doesn't change the function value. So f of -1 is the same as f of 1, f of -5 is the same as f of 5, so on and so forth. Is it okay? And in this case, if you're taking the integral of f of x from -a to a, this is going to be 2 times the integral from 0 to a, right? And that's because the area on both sides, so on both sides you have equal amounts of areas. So taking the integral from -a to a, that's the same as saying 2 times the area from 0 to a. Questions? Okay. Yeah. So let's look at one quick example. Let's consider the case, consider the integral from -pi to pi of the function sine of x. What is it? Is sine of x an odd function or is it an even function? Okay, so it's an odd function because the graph looks like this. This is a -pi, this is pi. Right. Another way of saying odd function is when you rotate the graph by 180 degrees, you get the same thing again. And it's obviously true for the function sine of x. So it's odd. And for odd functions, when you're taking the integral from negative something to something, it's always going to be 0 because the area above x is the same as the area below x. Questions? No? All right. Moving on to the last topic of the course. So this is section 5.1, the areas between curves. So let's recall what is the area under the graph again. So L is for the function for positive functions. Let's just consider positive functions f of x. That means it's always above x. Then this integral right here is the area under the graph of f of x from a to b. So that's the same as, so if your f of x looks like this, then the integral of f of x from a to b is going to be the shaded area here. Is that okay? So that's what we have done so far. And now the question is, if I give you two functions and I want you to find out what is the area between those two functions, what do? So here's the following. Here's the following situation. So the first situation is, I guess I should just write, we want to find area between two functions f of x and g of x. The first scenario is when f of x is always bigger than g of x. So in which case you have something like this. And then I want to find out what is this. So I want to find out the area between f of x and g of x. That means I want to find out the area of the shaded region here. So what do I do? What do you think I can do? Yep, so we could do the area of f of x minus the area of g of x. So we can do the area of f of x, which is this, minus the area of g of x. Does it make sense? So when you're subtracting the area of g of x, you're subtracting this area here. So that's the second term. And when you minus that, you're going to get the shaded area as required. And by the property of integral, this is the same as f of x minus g of x. And then you take the integral. Is it okay? So if one function is always above the other function, what you do is you take the integral of the top function minus the bottom function. So top, bottom. Questions? Okay. Second situation, if f of x minus g of x changes sign, then we need to find intersection points and compute integrals separately. So what I mean is, so let's say your f of x looks like this. This is f of x. Let's say your g of x looks like this. Say this is A, this is B. Let's call this one C. No. Let's call this one C, this one D. So C and D are the intersection points. And then I want to find this area plus this area plus this area. So Once you find out what are the intersection points, so these two are intersection. Right, so those are the x values when the graph of f of x and the graph of g of x cross each other. And so on the region from A to C, which one is top, which one is bottom? Okay, f of x is top. So from A to C, you would do f of x. From A to C, you would do f of x minus g of x. And from A to C. And between C and D, you do g of x minus f of x. And finally, from D to B, f of x is on top, g of x is bottom, so f of x minus g of x again. Is it okay? Does it make sense? So my point is, in general, you have to find the intersection points first, and then set up your integrals. Questions? So you can see that what we have done so far is we want to make sure that the integral, whatever you put inside the integral is always positive, right? So for example, in this situation, f of x minus g of x is positive from A to C. So from A to C, f of x minus g of x is positive. The same for D to B. So from D to B, f of x minus g of x is positive. Whereas from C to D, g of x minus f of x is positive, right? So we want to make sure that everything inside the integrals is always positive. And so in general, the area between two functions, two curves, is going to be, so if I want to do from A to B, I want to make sure that whatever that's inside is always positive. So what I can do is I can take the absolute value, f of x minus g of x. Does it make sense? So let me say this again. If I give you two functions, like very concrete functions, like formulas for the functions, the way you find area between two curves is to go through the procedure that I just did here. So you find intersection points, and then you see which one is on top, or which one is top, which one is bottom on which region, and then compute the integrals separately. The only reason that I'm making a remark here is because you could get a multiple choice question like, what is the area between two curves f of x and g of x? And that's when the case where you need to know this is the answer. This is not good in practice. You never use this formula in practice, but you need to know at least for multiple choice questions. Is it okay? Any questions? No? Okay. The first example is find the area between two curves f of x equals negative x plus 2 and g of x equals x squared. So I need to know what they look like in the graph. Okay, so I think I have someone that doesn't have a name here. So could you check if you have your name on the participant list? I mean, I don't want strangers in the group. Someone whose name is just the telephone number. It's 1734657972. Could you change your name? Otherwise, I'm kicking you out in 3 seconds. All right, bye. Okay, let's continue. So f of x equals negative x plus 2, g of x equals x squared. I need to know what they look like in the graph. Negative x plus 2 looks like this. And g of x equals x squared, it looks like this. And so the question is, I want to find the area between these two. So the shaded area there. What is the first step? What do I need to do? I mean, the first step I show you, so draw the graphs of f of x and g of x. What's next? Okay, so we know that f of x, from the graph, you know that f of x is always on top of g of x. So you would set up your integral like f of x minus g of x, right? But what is the lower limit and upper limit? How do I find them out? Um, so you look at the intersection points. So I want to find out what is this point and what is this point. So how do I find intersection points again? Okay, you set them to be equal. So you have x squared and negative x plus 2. So to find the intersection point, you set them to be equal. So you set x squared and negative x plus 2 to be equal. And so what you get is x squared plus x minus 2 equals 0. Factor that, you get x plus 2, x minus 1 equals 0, which means you have x equals negative 2 and x equals 1. And so this means this is a negative 2 and this is 1. Does it make sense? Is it okay? Any questions? All right, so now you would set up your integral. So the area now becomes, you know from the graph that f of x is always above g of x. So you just do f of x minus g of x. And then the lower limit is negative 2, and then the upper limit is 1 from what we just found. So f of x was negative x plus 2, g of x is x squared, just plug them in. So negative x plus 2 minus x squared, like this. Is it okay? And then just compute the integral as usual. Find an antiderivative and then plugged in 1 and negative 2. You're going to get 9 over 2. And that's the area between two curves. Questions? Do I need to find the antiderivatives for you guys? Any questions? Okay. Let's do a slightly more complicated example. So find an area between the following two curves. F of x equals x cubed and g of x, well, actually, between multiple curves, f of x equals x cubed, g of x equals x equals negative 2, and x equals negative 1. I guess it's the same as saying, yeah, it's the same as saying between these two curves from x equals negative 2 to x equals 1. All right, first step, what do I need to do? First step, what do I do? Draw the graph and find intersection points. So f of x equals x cubed looks like this. And y equals, sorry, g of x equals x looks like this. So this is f of x, and this is g of x. Is it okay? And then you want to find out what are the intersection points. So I want to find out what is this one, and this one. To find intersection points, you set them to be equal to each other. So x cubed equals x. So x cubed minus x equals 0. If you factor that, you're going to get x times x plus 1, x minus 1 equals 0. Is it okay? Questions? Right. And so I have x equals 0, x equals -1, and x equals 1. This is -1, this is 0, and this is 1. Remember that I want to find the area between two curves from -2 to 1. So I need to extend my graph, and -2 is somewhere here. So I have 3 regions. First one is here. Second one is here. Last one is here. Is it okay? So how many integrals do I need to set up? 3. So for 3 different regions, the first one is from -2, excuse me, from -2 to -1. Second one is from -1 to 0. The last one is from 0 to 1. Let's do that. So area, I have 3 integrals. The first one goes from -2 to 1, sorry, -2 to -1. The second goes from -1 to 0. The last one goes from 0 to 1. Now for -2 to -1, what do I put inside the integral? So which one minus which one? Yep, so g of x is on top of f of x, so you do x minus x cubed. Does it make sense? So from -2 to -1, the green region, the line is above the x cubed, so x minus x cubed. From -1 to 0, the blue region, which one minus which one? Yep, the other way around. So you do x cubed minus x for the second. And finally, for the last, you do g of x minus f of x, because g of x is on top. So again, x minus x cubed. Does it make sense? And just compute the integrals as usual. So find the antiderivative, and then plug in the lower and upper limits. Is that okay? Questions? Okay, we still have time today, so I want to do one example from the web work. Oh, wait. So, so the examples we did so far, we always set up the integrals in terms of the variable x, right? So we're always using x here and then dx, x, dx. And the reason is because um, in these examples, we can always draw we computed the area using the vertical rectangles. I'll explain that in a second. Actually, I'll explain it now. So can't find my notes. So what I'm saying is, let's say this is my f of x. Say this is my g of x. So this is a, this is b. So the way I do vertical and horizontal is because is as follow. So if I can draw a rectangle like this, so if you remember that when we first define the integral, it's defined to be the area of rectangles, and then you take the number of rectangles to be infinite, right? And so if you can do the vertical like this, so that means, so I'm saying that the top is one function and then the bottom is another function. Let me write this out. So if the top here is one function and then the bottom is a different function, then that means you can do the vertical one and say that the area under the graph, the area between two functions is just this. And I'll show you in a moment when can I do horizontal. So there are cases that look like this. So in this case, I have x in terms of y. So let's say x equals h of y. Then let's say I have another function, x equals g of y. And I want to find out what is the area between these two curves. In this case, I have to do horizontal. And then the reason is, if I draw it vertical, on this region, I would have, well, on one end is one function, on the other end is a different function. Sorry, on one end is h of y, and on the other end is the same function, h of y, which is not good because you don't want the top and bottom to be the same. And on this side, you have the top is g of y, and the bottom is the same g of y, which is not good. And in this case, I want to do horizontal. Yuck. So for horizontal, you would do the right-hand side, the right function minus the left function. So in this case, you would do g of y minus h of y. And then the integral will be in terms of the variable y. And then the lower limit would be this point here. And then the upper limit would be this point here. Let's call them c and d. And so the integral will become c to d. Questions? Okay. Give me 1 minute. I'll come back in a minute. Okay, so let's look at this one. So I just want you to identify whether it's horizontal or vertical. So for the first one, what do you think? Do we do vertical or do we do horizontal? So for I cannot draw. So for this one, what do I do? Do I do vertical or do I do horizontal? Okay, vertical. And that's because, let's try to do it. So if I draw a rectangle, a vertical triangle like this, the top end is one function, and then the bottom is a different function. So that's fine. So we do vertical. So your integral should be in terms of x. Does it make sense? And then you can see that you cannot do horizontal because, for example, on this side, if you do horizontal, then it's fine. The left side is one function and then the right side is a different function. That's fine. But if you do horizontal here, the left side comes from the same function as the right side, which is not good. Does it make sense? Is it okay? All right, for the second one, vertical or horizontal? So in this example, do I do vertical or do I do horizontal? We do vertical. Again, let's try to see why this is the case. So if I draw a vertical box like this, you can see that on one end, the top is one function, the bottom is a different function, so it's fine. So that means I can do vertical. Again, it's in terms of x because it's vertical. And why can I not do horizontal? Let's see. So on this side, if I do horizontal like this, on one end, it's one function. On the other side, it's just a number, which is fine. But the problem is when you go to the bottom, the left side would become a different function as the top. Does it make sense? So for the top, you would be using this function. But when you go down to the bottom, the left side becomes this function. Last one. So vertical or horizontal? Horizontal. Yeah, actually, this is a good example. Let's finish this. Yep, so let's say I want to find the area between these two curves. So I want to find this region. And someone say that it's horizontal. Well, because I mean, you can see right away that if you draw horizontal, if you draw vertical, on the left side, you'll be doing a different function as when you're doing the right side. So in this case, you're doing horizontal. So the integral would be right function minus the left function. So what is the right function? The right side is y equals x squared, right? And recall that if I want to do horizontal, everything has to be in terms of y. So you want to put x in terms of y. This is y equals x squared. So x equals, so if y equals x squared, what is x? If y equals, yep, square root of y. Technically, you have to be careful. So is it positive y or is it negative? Is it positive root y or is it negative root y? Are we on positive side of x or are we on negative side of x? Positive. So the right hand side is the positive part. This is the positive part. So you take positive square root of x, square root of y. So this is a function that I'm going to use. The right function minus the left function. So the left function is y squared equals x plus 1. And I need to put x in terms of y. So x equals if y squared equals x plus 1, then x equals y squared minus 1. This is a square. So y squared minus 1. That's a function that I use for my left function. So this is root y minus y squared minus 1. Is it okay so far? And then I need to find out the lower limit and upper limit. So I'm doing horizontal. So I need to find out what is the lower limit and what is the upper limit for y. What is the lowest y can go? So what is the lowest y starts from? It's 0, right? And then the highest point, from the graph, you can tell that it's 1. So 0 here, 1 here. So from 0 to 1. And then you do the antiderivative. Last thing, plug in 1 and 0. Does it make sense? We'll do a couple of examples on Wednesday. Yeah. Any questions before I let you go? Any questions? All right, 1 minute. All right, if you don't have any questions, I will see you on Wednesday.